We're going to solve the system of linear equation by Gauss elimination method. We have the equation x minus 2y minus z equal to 3, 3x minus 6y minus 5z equal to 3, 2x minus 2y plus z equal to 0. So first we write in the augmented matrix form. So this is my solution. And as I said, always when we start, we write the augmented matrix form from this equation. So my augmented matrix form for this one is by taking the constants, coefficients of the system equation. I take here A, this is my matrix of coefficient, B, the matrix of constant, and this is here, we are having here A. Our A is, the first row is 1, minus 2, minus 1, and our B, 1 is 3. My second equation that give me 3, minus 6, minus 5, and 3. My third equation give me 2, and this minus 1, and we having here 1, and we having here 0. So I get here, this is my row 1, this is my row 2, this is my row 3. So as I mentioned here, that I want to change this to 1, and the below 1, the value will be 0. So what I want to make? I want to make this value equal to 0. I want to make this value equal to 0. To make this value 0, we make the following row operations. We multiply here by minus 3 and add to row 2. Minus 3r1 plus r2. This is my first row operation. That gives me the new row R2. To make this one 0, multiply by minus 2, add to this one. Minus 2 R1 plus R3. So in this way, we are able to change our augmented matrix form. And I can write here, this is my A, and this is my B. And I can just take here, with my row operations, the new form. The first row remains the same. I get here 1, minus 2, minus 1, and 3. And now for the second row, as I said, I multiply minus 3, I get here minus 3, I get here 6, I get here 3, I get here minus 9. Then row 2 is my row, that is here 3, minus 6, I get minus 5, I get here 3, I add it, I get here 0, I get here 0, I get here minus 2, I get here minus 6. So always I will like that you make this row operation separately, so you may be able to control that one, there is no mistake. So I get here new second row, this is 0, 0, and then is minus 2 and minus 6. Now I'm just going to do these operations for the third row, and as I said, I multiply my first row by minus 2, and then I'm going to add it to the last row. This is multiply here by minus 2, I get here minus 2, I get here 4, I get here 2, I get here minus 6. And my last row is 2, minus 1, 1, and 0. I add this one, I get here 0, I get here 3, I get here 3, I get here minus 6. So I change my third row by the new row, that is 0, 3, then is 3, then is minus 6. So this is my new matrix which I have reduced it. Now I want to reduce it in this form. Here I want to bring here 1. So here I have these two rows. And my first operation was that we can interchange two rows. So I can just interchange row 1, row 2, and row 3. I interchange row 2 and row 3. So I'll get here the new matrix by interchanging this one. I can just write here, this here is 1, minus 2, minus 1. I get here 3. And then the second row, that's here 0, 3, 3, and minus 6. And then I'm having here 0, 0, minus 2, and minus 6. Now what I'm having in my matrix here, in matrix I'm having here 1. So to bring the, in place of this 3, I just multiply by 1 by 3. Again I want to bring here 1. What I do? I multiply here my row 3 by minus 1 by 2. So my new operations will be that I'm having here, my new row 2 will be, I multiply here my row 2 by 1 by 3. So here the third row, I multiply by 1 minus 1 by 2, row 3. So in this way, I'll get this new matrix, and my new matrix here, I'm going to get it from the last one. So I just write it here. So that's near to the completion of our problem. So I just write it. I'm having here, after doing this row operation, I'll get here 1, 1 minus 2 minus 1 and 3. So I multiply here by 1 by 3. I get 0, 1, 1 and minus 2. 0, 1, 1 and minus 2. And this one, multiply minus 1 by 2, we get here 0, 0, 1 and 3. 0, 0, 1 and 3. So you can see here, the method we have just one, we have just matched it. This is our step 1. This here is our step 1. So here I can write, this was my step 1. And step 1 is elimination. So this method is two-step method. What is step 2? Our step 2 will be, we write the equation form and then we make back substitution. So this here is, I will show you in this example that how we get the back substitution. Through back substitution, we'll get the result. So here is our step 2. This back substitution. For this one, I will just write my matrix, argument matrix in the equation form. So again, we're having the variables x, y, and z. So my first equation become here x minus 2y minus z equal to 3. Get here y plus z equal to minus 2. I get here z equal to 3. So this is my equation form. And as told, we can solve it by back substitution. So we use the back substitution and get the value of x, y, and z. That's my solution. So I have the value of z equal to 3. From equation 2, we get here y plus 3 equal to minus 2. That give y equal to minus 3 minus 2. That means y equal to, that give me y equal to 5, minus 5. So my y equal to 5. Now I substitute the value of y and z in my first equation. I get here x minus 2y become here 10. Then minus z become minus 3. This is equal to 3. So that give me x is equal to minus 7 plus 3 is equal to minus 4. So I can say here my solution of the system, I get a unique solution. The system is consistent. I get the value of x minus 4, y minus 5. I get the value of z equal to 3. That's my solution of system modification. Again, we have two-step method. This is my step 1. In step 1, I have the elimination. And I get here the matrix in the following form. Here, this is my form of elimination. My step 2 is backward substitution. And we write the equation, system of equation. And then we substitute z. And then we substitute y. And then we are having the value of x. So in this way, our z is 3, substitute the value of z. We get y plus 3 equal to minus 2, y is minus 2, minus 3, minus 5. Then put the value of y and z here. We get the value of x is minus 4, so that's my solution. So this method, we say this method is Gaussian elimination method. So our second method is Gauss-Jordan elimination method. We have just discussed Gaussian elimination method. In Gauss-Jordan elimination method, we have one-step method. Gauss-Jordan method was two-step method, was elimination and back substitution. So I explain you the method. Our second method is method 2. The Gauss-Jordan method. We say sometimes Gauss-Jordan elimination method or Gauss-Jordan method. So here we're having the system of equation A11, x plus A12, y plus A13, z equal to B1. We're having A21, a general form. I'm just taking just to explain the method, and then we take the example to explain this one. This is my second equation. And my third equation is A31x, A32y plus A33z. So always, as I said, we will write the argument matrix form for my system of equation. And my argument matrix form is AB. A is the matrix of coefficient, B is the matrix of constant. So my coefficients are A11, A12, A13, A21, A22, A23, A31, A32, A33. I'm having here my matrix of constants B1, B2, B3, and as again I will mention here, this is my row 1, this is my row 2, and this is my row 3. So here we are going to apply our row operations And row operation number 1, we can interchange 2 rows. Number 2, multiply row with a non-zero real number. Number 3, we can add multiple of one row to another. By making this row operation, we just reduce this matrix in this form. So we are having here 1, again 0, 0, as we did in Gaussian elimination method. Then we are having here 1, and we are having here 0. But now we are having 0 here also. Again, we are having here 1 as Gaussian elimination method, but now we make all the values above also equal to 0, and we get here this B1, B2, and B3. We just better write here this instead of B, we write here S1, S2, and S3. So this is my X. My solution will be X equal to S1, Y equal to S2, and Z equal to S3.